Quantum code exposed. Researchers have written quantum code on a silicon chip for the first time. Shout out goes to Jose. Thank you for sharing this on my Facebook wall. It's very, very interesting. This is from an article from November 17th, so really recent. You can find the article in the description below. It says, for the first time, Australian engineers have demonstrated that they can write and manipulate the quantum version of computer code on a silicon microchip. This was done by entangling two quantum bits with the highest accuracy ever recorded, and it means that we can now start to program for the super powerful quantum computers of the future. This is something that I've been saying for a long time, that quantum computing is our future, so we should learn as much as we can about it now, because it's going to it's going to change everything, just like the internet did. It says engineers code regular computers using traditional bits, which can be in one of two states, 1 or 0. Together, two bits create code words that can be used to program complex instructions. But in quantum computing language, there's also the possibility for bits to be in superposition, which means they can be 1 and 0 at the same time. This opens up a vastly more powerful programming language, but until now researchers haven't been able to figure out how to write it. Now, engineers from the University of New South Wales in Australia have demonstrated that not only can they do this, but they can do it on silicon microchips very similar to the ones that make up today's computers, which means the technology will be easy and quick to scale up. So how exactly do you write quantum code? It all comes down to a phenomenon known as quantum entanglement. When two particles are entangled, it basically means that the measurement of one of them will instantly affect the state of its entangled particle, even if it's thousands of kilometers away. This effect is famous for puzzling some of the deepest thinkers in the field, including Albert Einstein, who called it spooky action at a distance, said lead researcher Andrea Morello from the Center for Quantum Computation and Communication Technology at UNSW. Einstein was skeptical about entanglement because it appears to contradict the principles of locality, which means that objects cannot be instantly influenced from a distance. But entanglement has been demonstrated time and time again through something known as Bell's test, which requires engineers to violate Bell's inequality principle. Basically, Bell's inequality principle sets a limit for the amount of correlation there can be between two classical bits. Anything above that must be quantum entangled. The key aspect of the Bell test is that it is extremely unforgiving. Any imperfection in the preparation, manipulation, and readout protocol will cause the particles to fail the test, said one of the researchers, Juan Pablo de Jolian. Nevertheless, we have succeeded in passing the test, and we have done so with the highest score ever recorded in an experiment. In their experiment, the two entangled particles in question were the electron and the nucleus of a single phosphorus atom, which was placed inside a silicon microchip. By entangling the two particles, they made it so that the state of the electron was entirely dependent on the state of the nucleus. This meant that they expanded on the four possible digital codes that can be made with two traditional bits, 00, 01, 10, or 11, to being able to create a much wider set of code words with two entangled bits, such as 00 plus 11, 00 minus 11, 01 plus 10, or 01 minus 10. This is, in some sense, the reason why quantum computers can be so much more powerful, the team member Stephanie Simmons. With the same number of bits, they allow us to write a computer code that contains many more words, and we can use those extra words to run a different algorithm that reaches the result in a smaller number of steps. The next step is to entangle more particles and create more complex quantum code words so that the team can begin to program an entire quantum computer. All the other pieces are already in place, in large part thanks to another UNSW team, which just last month built the first logic gate in silicon. The material is important because it's something we're already incredibly familiar with building computers out of. Now we have shown beyond any doubt that we can write this code inside a device that resembles the silicon microchips you have in your laptop or your mobile phone, said Morello. It's a real triumph of electrical engineering. The research has been published in Nature Nanotechnology. So what do you guys think? What do you think about quantum computing? I have my own reservations about it. Um, I think there's just a lot that's unknown, and even when they first started experimenting with these things, they said that the quantum it was really unstable. So I don't know if they were able to stabilize that or not. It's not specific in the article, but I don't know. I mean, it would be there's just so much that opens up from something like quantum computing coming into the world. But I do think that it's a future that we are headed towards. I don't think there's any way around it. So we got to learn to deal with it. But I'm interested in what you guys think as always. So leave a comment below if you haven't done so already. Subscribe to my channel and share this video. All right, thank you for watching. Take care and God bless.